Now let us suppose if I'm just talking about the converse of the previous theorem, means I'm just talking about the theorem number 2, which says that if the angles subtended by the chords of a circle at the center are equal to each other, then the chords are equal. Means now I just have to prove that the chords are equal to each other. So for an instance, if I'm just forming up a figure over here, let us suppose if I'm just taking this circle. If I'm just forming up this particular circle having the center as nothing but this particular point, which is nothing but called as O, and again I'm just forming up the same figure that I have formed for the previous theorem. Let us suppose if this is the figure that I'm taking, let us suppose I'm calling it as A, B, C and D, and these are the chords that I'm considering. Okay, so now what we have to prove over here, it is given to us that the angles which are subtended by the chords of a circle at the center are equal to each other. Means it is actually given to us that this angle is actually equal to this angle. This is already given to us. So let us suppose if I'm just writing it over here, that given is a circle and two chords such that the angle subtended by them at the center O are equal. That is, angle AOB is equal to the angle COD. So it is already given to us. So what we have to prove over here, we have to prove that AB is nothing but is equal to CD. Means the length of the two chords are actually is equal to each other. So let's just start with the proof of this particular theorem. So first of all, the proof of this particular theorem would be like, in the triangle AOB and the triangle COD, in the triangle AOB and COD, we can say that OA is equal to OC, being the radii of the circle. Further, OB is equal to OD, again the radii of the circle. Again, the angle AOB is given to us, which is equal to COD, which is already given to us. Then by these three things we can say that the triangle AOB is congruent to the triangle COD by SAS congruence criteria, because side angle side, we have this side equal to this side, we have this side equal to this side, and this angle is equal to this angle. So by SAS congruence criteria we can say that the two triangles are congruent to each other, and hence further AB should be is equal to CD. Why so? Because we know that the corresponding parts of the congruent triangle, they are also equal to each other. So the corresponding parts of the congruence triangle, we are taking them as nothing but the CPCT. So hence AB is nothing but is equal to CD, and this is exactly that we have to prove over here. So hence this is nothing but proved that if the angles subtended by the chords of the circle at the center are equal, then the chords are also equal.